Greetings, this is a video to take you through marble slide lines. So this is the preliminary video. It's just to kind of take you through the warm-up and verifies that they did. So this is the first screen that you get introduced to. It says, here's the goal, get all the stars, get to know lines. So one of our main goals in this activity is to come in and work with our pal, let's get over here, y equals mx plus b, okay? So recall that m is your pal, the slope, and there are many ways of getting the slope. One way is using the slope formula. Let me finish writing this down first though. Slope formula is y2 minus y1 over x2 minus x1. In other words, you can pick two ordered pairs and calculate the slope that way. But also recall that when you're working on a graph, if you have the graph of a line and you can easily identify 2 points on that graph, if you can come in and basically by counting, you can look at the rise and the run. In other words, we know that this is delta y. We know this is delta x. And one of the alternate definitions for the slope is the change in y over the change in x, or as carpenters call it, the rise over the run. Okay, so the second thing we need to recall is that this point right here, b, or this number b, comes with the order pair 0, b, more commonly known as the y-intercept, or many times it's referred to as the vertical intercept. So it tells you where we cross the y-axis. So with those two numbers, we can generate pretty much any line. Notice that the slope will change the angle of the line. So if I was to draw on a second line here on my graph here, notice that that line is going to have a very different slope or steepness than this line. In particular, let's go ahead and actually change that a little bit. Let's make that a little more obvious here. This slope would be positive and would be slightly less steep than the black line, okay? Or if I bring in, say, a magenta line here, where, let's say, it looks like this. That line is still got a negative slope, but it's shallower or not as steep as the black line, okay? So those things should look familiar to you. If they're not, you may need to take a few moments to go review your stuff about slopes, okay? All right, so one other thing is, how do I calculate this number here, the y-intercept, how to get that value? Well, I can do it from a graphical standpoint by simply coming in and reading that point off of the y-axis. Where does it cross the y-axis? This point right here is the point 0, b, all right? Now, there are, of course, other ways of doing it. We can come in and go, okay, well, you got y equals mx plus b. If you know what m is and you know what an ordered pair is, you plug all those things into the proper spots and out pops b. Okay, enough of the preliminaries. Let's go ahead and get working on marble slides. So this is a little demo one to show you that what your idea is you want to go in, launch your marbles, and take out all the slides. So the first thing they ask you to do is to get you familiar with how you're going to play this game, is go in and change one number in this equation down below to see if you can take out all the marbles. Well, the steepness looks good. Looks like it's parallel to my row of stars down here. It's just I'm shifted up too much. So we know what the y-intercept does, is it changes the position of the graph. It's basically a vertical translation, okay? So let's come in and let's change that. Let's see if we go down here. Looks like what? Looks like we're coming down, and we're going to go through, like, say, what, -2, okay? So let's change that 1 to a -2, and yeah, looking like I'm going to do really good here now, right? So I go launch, and voila, I have success. I've got them all, right? Okay, let's try doing some more. So this is just a little reminder that if you get all balled up, sometimes you start putting a bunch of lines in there and it gets all ugly and you want to go back to the original. You can click on that and reset it and take everything quickly back to the beginning, okay? All right, so change one number in the row below to fix this marble slide. Well, this time the y-intercept's looking good. Looks like if I launch my marbles, it would come through the right place down here at 3. Just my slope is too steep. So one way of calculating what you think the slope would be is to go ahead and do a counting thing, like I said. So if I go down 1, 2, to the left, 1, 2, 3, 4, it looks like my slope is 1/2, but since this is a positive line, that's going to be a positive 1/2. Keep that in mind. If it was a negative slope, it would have been a negative 1/2. So I'm going to go 1 divided by 2, looking good, press launch, and sure enough, I've got all of my slides, okay? All right. So change one number here and below to fix the marble slide. Now, one of the things we're going to want to do is have line segments. We're not necessarily going to want our lines to go from negative infinity to positive infinity. So we're going to use the tool built into Desmos to restrict the domain of our particular functions. Notice, as it is right now, if I launch it, it's not long enough, and we missed the last 2 stars. The other thing to notice, too, is the behavior of these marbles. They act as if they're under the influence of gravity. So when they come off, they fall almost like a parabolic arch. They don't just fall straight off, okay? So they have a little momentum, some getting them move, but not enough to keep them going straight, okay? All right, so it looks like we need to extend this. Let's go out to, I don't know, let's say 7. Take that out to 7. Notice that lengthened my line. And oh, look at that, success. Okay, you may not have got 7 on the first try, but try again. You may have to use a couple of tries to get to it. All right, so what about this one? Okay, how can we fix this one? So they're going to ask us to not only put in a domain restriction, but possibly a second line. They say add as many equations as you need to get all the stars. Well, first off, we can see the line is too long, so we need to bring it back a little bit. So let's bring it back to say, oh, I don't know, we can bring it back to 8. So make the x's bigger than 8. Okay, and notice that's going to, when we launch, that's going to get those 2, but it's going to overshoot the rest of our stars. Okay, so 8 may have been a little too optimistic there. Let's try 10. Okay, maybe even better yet, let's go 9. 9, lovely number 9. Okay, so let's try 9. Yeah, still going to overshoot that first star, so that's not going to work. So maybe 10 was the right number. Let's try 10. Okay, so I got 3 of them, but I'm just going to need a second line to catch that 4th star. So let's come in and do that. So let's see. So the slope still seems to be 1/2 because they seem to be parallel to our upper 2 stars. So y equals 1 divided by 2x. Okay, oops. I'm going to get that out of the denominator. We're going to get a rational, which we don't want. But I need to shift that thing up. So it's looking like the intercept in this case is going to be at 3. So let's go plus 3. And notice I'm going to catch those 2 stars, and then I catch my lower 2 stars. So that's a big hint in this fix-it, that you have to, many times in many of these challenges, use multiple lines in order to catch all of the stars, okay? All right, let's make a prediction here. It says we change the negative 0.14 to a 2 in the equation, what will happen to the graph? Well, notice we're going from a negative slope to a positive slope. So that means we'll go from an decreasing. Let's get my cart before the horses here. We'll go from a decreasing line to an increasing line. What else is going to happen? The new line will also be steeper. Okay, all right, so share that with class. Lots of other students that are signing in and doing it too, looking good, okay? So now they say go ahead and verify that. Make sure that it really did what you said it was going to do. So let's change that to a 2. And look at there. Sure enough, it's steeper than the original line. This was shallower, and we went from an increasing line from a decreasing line. Okay? All right, let's go to verify number 2. Well, actually, we have to predict first. It says what happens if you change the 3 to a 0? What will happen to the graph? Well, if we change the 3 to a 0, then that means that our y-intercept will be a 0, and we're going to go through the origin. So the graph will go through 0, 0, better known as the origin. Okay, so let's share that with class. And then let's go verify that. So let's see if that actually works. Oops, put it into X. Now, if you want, you can put in a plus 0, but notice it doesn't change anything. You can just leave it like that, and that's all well and good, okay? Notice that it gives us the original line plus the one that we checked with. Okay, predict number 3. If we change the 2 to a 5 in the domain restriction, x less than 2, what will happen to the graph? Well, the graph is going to extend all the way over until it hits over here at the 5, right? In other words, it'll pull the line further to the right. Line will lengthen to 5 on the x-axis. Okay, now of course these solutions are not unique. There's many ways you can say what I'm saying. If you wrote it differently, but had still the essence of what happened to the graph, then you're good to go. Okay. All right, so let's go ahead and do that. Let's throw the 5 in here. Sure enough, it stretched the line over to a 5, okay? All right, predict number 4. Your friend isn't going to get many stars like this. So what changes would you make to the equation to help your friend collect all the stars? Why are these changes going to work? Okay, so you need to tell them basically as if you were texting them. You're not using a lot of symbolic stuff here. So you're texting them how to help them out here. Well, the first thing you're going to need to do is change the slope. Y-intercept's looking pretty good, right? But I think you need to change your slope. I think you got your slope a little messed up. I think you wanted to have 2/1. If you look at your rise here, it was 2 and your run was 1. So I think you got the slope backwards, okay? So the first thing is change the slope to 2/1 instead of 1/2, okay? All right, now the second problem they've got, this is their domain restriction. They're too far, they didn't let the graph come over far enough, okay? So what they need to do is make that domain restriction come over to, oh, let's see, 1, 2, 3, 4, 5. Let's go over to 6, okay? Domain restriction, there we go. Domain restriction 2x less than, let's say, 6, okay? So I'll share that with class. Let's go give it a go. Now I'm going to say, do it, okay? So let's give it a go. So we'll go till 6 there. Oops, go to 6, okay? And then we're going to change this to what? To 2, right? Make the slope 2. Okay, let's see if that worked. Bada bing, bada boom, we got them, okay? All right, so that's the preliminaries. We're going to go ahead and stop this video here, and we'll come back in just a bit and start working on some of the challenges. I strongly suggest that you give them a go on your own first before you watch the solutions. Not going to help you in the long run if you watch the solutions before you actually do them. Second thing is, my solutions may be very different from yours, and that's okay, provided that you just killed all the stars. Strive for efficiency and try and do it in the least number of lines possible, but the reality of the situation is if you got the stars, you rocked it, okay? All right, we'll be back in a minute. We'll start working on solutions.